Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 11 students studying MCR 3U who are looking for solutions to the practice exam questions. This is video number 6 where we'll look at question number 21. It says consider the following function. So we start with function f at x, 1 over 2 to the negative x. So for each function state the domain and range, evaluate f at negative 5 and determine the equation of the inverse. So let's look carefully at this function. It's obviously based on the function y equals 1 over x, but I want to rewrite it because I don't like seeing 2 minus x. I don't know what to do with that. So what we're going to do is instead of writing 2 minus x, we're going to write negative x plus 2. So I haven't changed anything. I still have negative x and I still have positive 2. Now I'm going to factor out a negative sign so that it looks more familiar to me. So x minus 2, and there's a negative sign. Now I can leave that negative sign down here, or I can move it to the top. Let's move it to the top. Negative 1 over x minus 2. There. Now I'm incredibly familiar with this graph. So again, the original graph had asymptotes that intersected at 0, 0, and it had this reciprocal function where I had a point at 1, 1, and so on. So what does the negative sign here mean? Well, that means that we've actually had to reflect this over the y-axis. Now, what you'll notice that's interesting is if I'd left it like this, it would have been a reflection over the x-axis, which would end up looking the same thing. So here's what the reflected looks like. Sorry, my drawing's not so great. But here's it reflected, and again, you consider that a reflection over the x or the y. It doesn't matter. It looks like this. I also know that I've moved everything to the right by 2. So my asymptotes are actually going to intersect at this green intersection. And my equation is actually going to look like this. So let me clean this up a little bit for you because I know I made a big mess. And let me pull out my awesome line creator. So if this is the normal xy axis, I'm now going to have asymptotes. Instead of at x equals 0, y equals 0, I've moved to the right by 2. So my asymptotes are actually going to intersect right here. And also, because of the reflection, instead of going 1, 1, I'm going to go 1, down 1. So I actually end up with this graph. So the whole point of one of the big messages of MCR3U is be able to draw a quick sketch of a function, because then no matter what, we should be able to answer questions based on it. For example, what are the domain and range? So look at the visual. Domain is all values of x that are legal to be subbed into this equation. So can I sub in a value of x negative 10? How about x negative a million? How about x negative 2? How about x 0, x1, x4, x40? So what are the values of x that I'm allowed to sub in? So two ways of doing that. Look at the diagram. It's pretty clear that at x equals 2, I've got a problem. Everywhere else, I've got a graph. So I know x cannot equal 2. I can also determine that by looking at the equation. Here's where x is. It's at the bottom of a fraction. So the only restriction would be where the bottom of that fraction was 0, and that's at x equals 2. So by either looking at the graph or the equation, we know that the domain is all real numbers are perfectly fine except for 1. So we say the domain is all values called x, where x cannot equal 2. Otherwise, go ahead and let x be any real number that you want. So let's talk about the range. So the range is basically when I start substituting values of x in, what values of y are going to occur. I always find range far easier to look at if I know the graph. I can see that I've got negative infinity and negative a million and negative 3 and all the way up to not quite 0. So all the negatives, I'm going to find them. All the positives, I'm going to see them. So I've got 0.001 and 1 and 12 and 480. But I'm never going to see this horizontal asymptote. There is no value of x that you can substitute in and get a value of y. So for example, it's impossible for me to solve for x in this equation. Think about it. If I try cross multiplying, so 0 times this is 0, negative 1. If I try cross multiplying, I get this impossible, ridiculous situation. And that's because there is no way of getting a value of y equals 0. So that tells you about your range. Your range is that for the y, you are going to see every single value of y. So every real number will occur except for 1. You are never going to see y equals 0 on this equation. So that was state the domain and range. Now evaluate. So evaluate, we need to evaluate f at negative 5. So looking at my graph, I know what sort of value to expect. That's why we like having a graph. So if my function says this, I think that's what it says, right? Yeah. So f at negative 5 is positive 1 over 7. So 1/7. And then finally state the inverse. Okay. Now, the way that your teacher had you do the inverse may be different from the way I'm about to do it. Don't worry, it's all the same logic. The way that I like to find the inverse is I inverse where x and y are. And then I do whatever algebra I can to isolate y. So now I need to write this explicitly as a y equals equation. So I switch the positions, and now I'm going to solve for y. So the first thing I need to do is get y out of the denominator. So in order to do that, I'm going to multiply both sides. I'm going to cross multiply. Now, I don't actually want to multiply x times y because that's weird and ugly. So that's why you see me write it as x bracket. So now I'm going to divide both sides by x, and that way I don't have to deal with x times y. So I get y minus 2 equals 1 over x. And now I'm going to add 2 to both sides, so y equals 1 over x plus 2. So that should be the inverse of the original function. And to write it as the inverse, I just looked at the answer sheet, and I guess in the answer sheet they want you to get a common denominator. All right, fine, I get it. So this has to be over x, so this would be 2x over x. So I'd get 2x plus 1 over x, and obviously x cannot equal 0. And to write this properly, we start it with f at x. So this is actually inverse, f inverse at x. Looks like this. Okay? So hopefully that was helpful, and let's go on and do it again, because I think there's a part B to this question. So now I have a quadratic function. So what do we know about quadratic functions? Well, we know that they generally look like this. This is the basic quadratic function. In this case, I've stretched it by 3 and moved it up 1. So instead of starting at 0, 0, we're starting here, and now we're going a much more narrow parabola. So over 1 up 3 instead of over 1 up 1. So the domain and range. You should be fairly familiar with the domain and range. The domain, think about the equation first of all. Is there a value of x, a number that you are not allowed to substitute in? So can you substitute 0 in? Sure, 0 squared is 0. That's legal. Can I substitute positives and negatives? Absolutely. And if you look at the graph, there's no asymptote or jump or anything weird that happens on the x-axis. Every single value of x is legitimate as a value that you can use in this equation. So we just simply say that domain is all real numbers. Now what about the range? Well, we know from grade 10 and grade 11 that a parabola has a minimum or a maximum. In this case, it's pretty clear the parabola has a minimum. And that means that there is no value of y that will ever be below where the vertex is. Well, we know where the vertex is because originally it was at 0, 0, and then we were told to move it up 1. So this line at y equals 1 represents the absolute minimum. So we know that all of the values of y are going to be above that or equal to that. So we say that y is going to be bigger than or equal to 1. So this value of 1 is the absolute smallest. Otherwise, you're allowed to pick any real number you want, and you're going to get a value in the range. So there's the domain and range of that parabola. Evaluate f at negative 5. So again, we substitute in. So So negative 5 squared is 25. 3 times 25, so it's 75. And then finally, to find the inverse, so I'll write it with a y, 3x squared plus 1. And now I'm going to reverse the positions of x and y. And then I'm going to try to isolate y. So subtract 1 from both sides. Divide both sides by 3. Now at this point I have to take the square root. And it's important that you remember that when you take the square root, you get two answers. So it's plus or minus the square root. And the reason why that is the square root function looks like this. That's only half a parabola. So plus or minus is how you get both sides of the parabola in an inverse equation. So again, now I just have to write this properly as the inverse of the function f. And there's my solution. There's no restriction because x, well, I don't have to worry about the denominator. That's what I want to say. There are restrictions, however, so let's talk about the restrictions. X minus 1 has got to be greater than or equal to 0. So x needs to be greater than or equal to 1. Okay, so make sure you remember to write domains and ranges. Okay, so that was question number, oh, I don't even remember. Question number 21. I hope that was helpful, and I'll meet you at question 22.